Today's learning target is I can determine the domain and range of functions. All right, so when we're talking about the domain, we're talking about the inputs or the x values. When we're talking about the range, go up here, I guess, we're talking about the outputs or the y values. Okay, so if we take a quick look at this box over here, with it gives you a bunch of different examples. So the domain, it's telling us these are all of our different x values, -1, 0, 1, 2. I'm going to try to stick with my green here for the domain. Okay, so take a look at the ordered pairs. Remember that the first number is the x coordinate. And I have 0, -1, 2, 1. Those are the numbers that we see listed here. All right, in the mapping, all of our inputs, -1, 0, 1, 2. Okay, that's these numbers here. They're all listed in our domain. If we look at our table, okay, the x values get listed first. Same numbers, okay? And on a graph, we can see this is our x-axis, and it goes here, -1, there's a point, at 0, there's a point, at 1, there's a point, and then at 2, the x value of 2, there's a point. Okay, so that's our domain. Our range is the outputs or the y values. Those are listed here, -3, 0, and 2. Okay, so if you take a look, remember that in an ordered pair, the second number is our y coordinate. So we have a -3, 2, 2, 0. Okay, now notice when the same number repeats, the same output or the same y value, if we're listing the range, we still only have to write it once because it's the same number. Okay, and if we look here, our outputs or our y values are the same numbers, -3, 0, 2. On a table, here is our y values. Okay, again, we see that 2 is repeating twice, but it's still a number in the range. And then on our graph, we see this is our y-axis here. So at -3, we have a point, at 0, we have a point, and then at +2 going up to, we actually have 2 points there. Okay, so those are, that's like the quick intro to what is it, the domain and range. Now, when we're talking about domain and range, we also have to talk about the different type of numbers that are shown here in this diagram. Okay, so I'm just going to quickly explain what we're talking about here. The natural numbers are like your counting numbers, 1, 2, 3, 4, 5, and so on. Okay, when we're talking about whole numbers, it's all of those counting numbers plus 0. Those are all the whole numbers. Okay, when we get to integers, we're talking about the counting numbers, the 0, but then we get into negative whole numbers, okay, like -3, -19. All right, but still in integers, it's positives and negatives, but they still all have to be whole numbers. Okay, then we get into our rational numbers. Rational numbers are all of those other sets, plus we start to add in fractions and decimals. Okay, we still can have positives and negatives, but we're adding fractions and decimals when we talk about rational numbers. Okay, and we're also, I should be a little more specific, we're talking about terminating decimals, meaning decimals that stop, not the ones that go on and on forever. Those are our irrational, excuse me, numbers. So like if you know pi, it's 3.14, blah, 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 blah. It keeps going. If you put in the square root of 2 and hit equals in your calculator, you'll get a long decimal that keeps on going, okay? Those are irrational numbers. Rational numbers stop. Rational decimals are a decimal that stops, okay? And then if you put all the numbers together, those are our real numbers.